Okay, so what we're going to do now is we're going to set up and understand the formula for calculating top of the atmosphere or at-sensor spectral radiance from the DN number included in the Landsat, or this also works for Sentinel and a bunch of other files anyways that you would have. So anything that you got a DN and you want to go backwards and actually figure out what the radiance was. Okay, so if we remember, we have this set up for Landsat, and this is Landsat 7, that in here we have spectral radiance, right? And what we're trying to do in here is calculate the DN. So this is spectral radiance come in, and this is the DN number that's calculated. We want to go backwards, right? We want to do this backwards. So I modified this graph to do it the other way. So because we're going to be solving for y, and we already know dn, we want to know spectral radiance. This is what happens. This is how spectral radiance is converted to dn originally in the Landsat. So a spectral radiance number comes in, there's a scaling factor, and then there's the gain of the instrument. Depends on which line you're using, how the gain was set, and how the bias was set over here. A little bit different when we're going back the other way. Here we know dn, right? And for Landsat 7, it goes 0 to 255, and for, or really 1 to 255 and 1 to 15, or 1 to 16,536 for Landsat 8. So in here we have high gain saturates at a lower spectral radiance. So this would be like if it's dark out, you would turn it on high gain, right? Notice that on this graph, it's got a lower slope, and it actually is at a lower value, right? And so over in here, the low gain has a steeper slope, but it saturates at a much higher spectral radiance. So this you'd want to use during the middle of the day. This you'd want to be doing in the evening hours if you had a camera or something like that. So we know these DN numbers. We want to convert them back, and the formula is pretty simple. It's just the spectral radiance for any given band equals the gain times the DN number of that band at that particular pixel, right? So each pixel is going to have a DN number. So you're going to have to do this millions of times, right? This calculation will have to be done millions of times to convert an image, plus the bias. Now notice on the first image when we were going from spectral radiance to DN, the bias was positive. Here the bias is negative. These slopes of these lines come back and intersect the y-axis at negative values, and we'll see that that's actually the case. So where do we get these numbers? We know where we get the DN number. It's just the pixel value for the band, right? We need to find the gain and the bias numbers. So there's two places that you can find these things. One is in the original header file, and I've copied it over into this thing right here. That's the MTL text file. So if I click on that header file, there's a whole bunch of stuff that you scroll down through, but you'll get to this thing that says Radiance Mult Band. So that's the Radiance Multiply Band. That's actually the gain. They decided not to call it gain anymore for Landsat 8. In Landsat 7 headers, you'll see it as gain. And then this is the bias or offset. So this is the B term, right? This is the slope of the line. This is the y-intercept in here. So if we look at here, here's the slope, and then these are in exponents. So this is -2, so it'd be 0.01279. And then down in here, this is the, right in here, this is the intercept. And notice they're all negative numbers, right? So negative numbers in here for bands 1 through 7, and that's just exactly what we had on our graph. So these are the numbers you want. Is there an easier place to get it? Yeah, there is. If we go over into Envy, these numbers, as long as you opened your original file and did everything right, they're actually in the Envy header. So if we view metadata, right, we can see this. If we view the metadata, oh, I've got it open down here. There it is. So there's the metadata for this guy, and I can widen this out a little bit to see the names. And I'll widen this a little bit. So what you see in here, here's the wavelength. Here's band 1, band 2, band 3, band 4, band 5. That's under spectral over here. Here's the wavelength of them. Here's the width of each one of those guys. And right there, there's the radiance gain and the radiance offset or bias. These are the negative numbers. These are the positive numbers, right? And these are the things that are going to go right into here. So this is just solving a simple equation like millions of times, right? Because we got millions of pixels, and in this one we won't have millions of pixels. We have quite a bit fewer. So that's the idea. That's where we need to get the data and how to do the equation to get top of atmosphere radiance. In the next one, I'll show you how to actually do that.